Soil structure describes the arrangement of the solid parts of the soil and of the pore space located between them. It is determined by how individual soil granules clump bind together and aggregate, and therefore, the arrangement of soil pores between them. Soil structure has a major influence on water and air movement, biological activity, root growth and seedling emergence. Overview. Soil structure describes the arrangement of the solid parts of the soil and of the pore space located between them. The structure depends on what the soil developed from. The quality of soil structure will decline under most forms of cultivation. The associated mechanical mixing of the soil compacts and shears, aggregates and fills pore spaces. It also exposes organic matter to a greater rate of decay and oxidation. A further consequence of continued cultivation and traffic is the development of compacted, impermeable layers or pans within the profile. The decline of soil structure under irrigation is usually related to the breakdown of aggregates and dispersion of clay material as a result of rapid wetting. This is particularly so if soils are sodic, that is, having a high exchangeable sodium percentage of the cations attached to the clays. High sodium levels cause particles to repel one another when wet, and the associated aggregates to disaggregate and disperse. The ESP will increase if irrigation causes salty water to gain access to the soil. A wide range of practices are undertaken to preserve and improve soil structure. For example, the NSW Department of Land and Water Conservation advocates increasing organic content by incorporating pasture phases into cropping rotations, reducing or eliminating tillage and cultivation in cropping and pasture activities, avoiding soil disturbance during periods of excessive dry or wet when soils may accordingly tend to shatter as met, and ensuring sufficient ground cover to protect the soil from raindrop impact. In irrigated agriculture, it may be recommended to apply gypsum to displace sodium cations with calcium and so reduce ESP acidicity, avoid rapid wetting, and avoid disturbing soils when too wet or dry. Impacts of improving soil structure. The benefits of improving soil structure for the growth of plants, particularly in an agricultural setting, include reduced erosion due to greater soil aggregate strength and decreased overland flow, improved root penetration and access to soil moisture and nutrients, improved emergence of seedlings due to reduced crusting of the surface, and greater water infiltration, retention and availability due to improved porosity. It has been estimated that productivity from irrigated perennial horticulture could be increased by 2 to 3 times the present level by improving soil structure. Because of the resulting access by plants to available soil water and nutrients, the NSW Department of Land and Water Conservation suggests that in cropping systems, wheat yields can be increased by 10 kilograms, half for every extra millimeter of rain that is able to infiltrate due to soil structure improvements. Hard-setting soil. Hard-setting soils lose the structure when wet and then set hard as they dry out to form a structureless mass that is very difficult to cultivate. They can only be tilled when the moisture content is within a limited range. When they are tilled, the result is often a very cloddy surface. As they dry out, the high soil strength often restricts seedling and root growth. Infiltration rates are low and runoff of rain and irrigation limits the productivity of many hard-setting soils. Definition. Hard-setting has been defined this way. A hard-setting soil is one that sets to an almost homogeneous mass on drying. It may have occasional cracks, typically at a spacing of NGT 0.1 meters. Air-dry hard-set soil is hard and brittle, and it is not possible to push a forefinger into the profile face. Typically, it has a tensile strength of 90 kilonewtons m2. Soils that crust are not necessarily hard-setting, since a hard-setting horizon is thicker than a crust. Hard-setting soil is not permanently cemented and is soft when wet. The clods in a hard-setting horizon that has been cultivated will partially or totally disintegrate upon wetting. If the soil has been sufficiently wetted, it will revert to its hard-set state on drying. This can happen after flood irrigation or a single intense rainfall event.